Hello friends, in this video we are going to discuss the circuit operation of single phase full wave controlled rectifier with RL load and with freewheeling diode, and the configuration is midpoint tapped transformer configuration. Okay, so here it is the circuit diagram, okay, which is same as that of the previous load, that is the RL load. The only thing is here we have connected the freewheeling diode, right? FWD is the freewheeling diode which is connected across the load, right? So now here Vs is equal to Vm into sine of omega t, right? So Vs is positive during 0 to pi, and from pi to 2 pi Vs is negative, okay? So when Vs is positive, plus here minus here, so here it is plus, here it is minus, this voltage is Vs, okay? Number of turns are here n has to 2n, okay? So what is the secondary voltage? It is a 2 times Vs, okay? So here it is a Vs, here it is a Vs. Highest potential will appear at the upper terminal of the secondary winding, lowest potential will appear at the lower terminal of the secondary winding, okay? Compared to this point, middle point is at the lowest potential, means because from here to here the potential is decreasing, okay? Next, compared to this point, this one will be at the higher potential, okay? So now when Vs is positive, it is like highest potential is appearing at the anode of thyristor T1, so thyristor T1 will be in the forward bias mode. Similarly, when Vs is positive, the lowest potential is appearing at the anode of thyristor T2, so thyristor T2 will be in the reverse bias mode, okay? So when Vs is positive, thyristor T1 get pulse is applied because thyristor T1 is in the forward bias mode. When Vs is negative, thyristor T2 will be in the forward bias mode, so we have applied the gate signal to thyristor T2. Similarly, alternately we are going to apply the gate signal to thyristor T1, thyristor T2, and so on, okay? So now this is about the circuit. Now we are going to discuss the circuit operation during different intervals, okay? So first, during omega t is equal to 0 to alpha, during omega t is equal to 0 to alpha, right? And this is for very first cycle, okay? For very first cycle only I am saying, okay? So now, so during omega t is equal to 0 to alpha, Vs is positive, okay? So Vs is positive, I am drawing only secondary side of the transformer, okay? No need to draw the primary side. Here it is a R, here it is a L, right? Whether we applied the gate signal to thyristor? No, gate signal is not applied to the thyristor, okay? Yes, this voltage is Vt1, here it is Vt2, right? Current is It1, current here is It2, okay? Next, freewheeling diode, it is in the open state, right? RL, okay? Load voltage is V0, load current is I0, current flowing through freewheeling diode IFWD, okay? This is Vs, here it is Vs, okay? So from 0 to alpha, yes, thyristor T1 is in the forward bias mode, but we have not applied the gate signal, so T1 will be in the forward blocking mode. What about T2? T2 will be in the reverse blocking mode, okay? So we can write it as T1 forward blocking mode, T2 reverse blocking mode, okay? So T1 is in the forward blocking mode, T2 will be in the reverse blocking mode, okay? Next, so both the thyristors will be in the open state only, okay? So if you check whether the current will be flowing from source towards the load, not possible, okay? So what is the load current? 0, I0 is 0, It1 is also 0, It2 is also equal to 0, and IFWD is also equal to 0, means all the currents will be 0, right? All the currents will be 0. Next, what is the V0? Yes, if you check, V0 is equal to 0 because current is not flowing through the load, okay? Next, what is the Vt1? Both the thyristors are in the off state, okay? So Vt1, can we write it as a, or if you can apply KVL, Vt1 is equal to plus Vs, Vt2 is equal to minus Vs, right? Minus Vs. So during 0 to alpha, for very first cycle I am saying, okay, for very first cycle, V0 will be 0 only, V0 will be 0, right? I0, it is a 0, for very first cycle it will be 0, but for continuous cycle it will be non-zero, okay? Next, for very first cycle, Vt1 is Vs, okay? So Vt1 is Vs for very first cycle as well as for continuous cycle I am saying, okay? This is. Next, this is till omega t is equal to 0 to alpha. So from 0 to alpha, it is like a circuit will be at the rest position. so current will not be flowing through the load, so current flowing through the inductor will be 0, right? So during 0 to alpha, inductor has not stored the any energy. Okay, next, now we are going to discuss from alpha to pi. Omega t is equal to alpha to pi. What will happen? Yes, from omega t is equal to alpha to pi. Yes, so from alpha to pi, yes, thyristor T1 is turned on. Okay, thyristor T1 is turned on. So mode of operation of thyristor T1, it is a forward conduction mode. Okay, so T1 is in a forward conduction mode. What about T2? T2 will be in the reverse blocking mode, right? T2 will be in the reverse blocking mode, right? Next, so current will be flowing from Vs, T1 load and again back to the Vs. Okay, so what is the V0? V0 will be same as that of the supply voltage. V0 will be same as that of the supply voltage, so it is a Vs. Okay, what will happen to the freewheeling diode? Yes, as this forward voltage will be appearing as a reverse voltage for the freewheeling diode, so diode will be in the off state. Okay, so what is the freewheeling diode current? IFWD is equal to 0 ampere. Okay, next, now if VT1 is 0, right, thyristor T1 is in the on state, so VT1 is 0 volt. What about the VT2? Right, out of the two thyristors, one is in the on state, so what about the voltage that will be appearing across the second thyristor? It will be minus 2 Vs. This total voltage is 2 Vs, but highest potential is appearing at the cathode of thyristor T2 and lowest will be appearing at the anode of thyristor T2. Okay, so therefore VT2 will be equal to minus 2 into Vs. Okay, minus 2 into Vs. Next, I0 for very first cycle, yes, I0 will start increasing and inductor goes on storing the energy. Okay, means from omega t is equal to alpha to pi, our inductor goes on storing the energy. Okay, so polarity will be plus here and minus here. Okay, next, so for very first cycle this I0 will be increasing. For very first cycle this I0 will be changing slowly. Okay, but for continuous cycle it will be a constant current. It will be a constant current. Okay, next, V0 is same as that of the supply voltage. What is the VT1? It is a 0. Okay, next, after pi till pi plus alpha, what will happen? Let us discuss. Okay, so from pi to pi plus alpha, so from alpha to pi, now inductor has stored the energy. Okay, and at pi, at omega t is equal to pi, if you check the current flowing through the inductor, that is a load current, is a constant current. It is a I0 now. Okay, it is a I0 and it is a positive current. Means what? Current direction is from right to left. Okay, now let us discuss for omega t is equal to pi plus alpha. Omega t is equal to pi plus alpha. What will happen? Yes, from pi to pi plus alpha, supply voltage is negative, so here it is a minus, here it is a plus, right? Here it is a minus and here it is a plus. Okay, so supply voltage is reversed. So now this supply voltage will try to circulate current in the anti-clockwise direction. This also will try to circulate current in this direction. Okay, but whether we have applied the gate signal to thyristor T2? No, so thyristor T2 is in the off state only. Okay, next, so whether the current will be flowing in the lower loop? Not possible. Okay, so here current will not be flowing through this loop, right? Next, what will happen? But this inductor will oppose the change in the current. Okay, this supply voltage is trying to circulate current in the anti-clockwise direction. Means in this branch, this supply voltage is trying to circulate the current from left to right. Okay, before alpha or at omega t is equal to pi, it was from right to left, but whether this inductor will allow the sudden reversal of the current? No. So whatever the energy stored by the inductor from omega t is equal to alpha to pi, now inductor will release the energy. Okay, so if you check, this inductor is having two paths available to release the energy. One is inductor can release the energy in opposition to that of the supply voltage, right? In opposition to that of the supply voltage, or inductor can release the energy through the freewheeling diode. Okay, but if you check, in the freewheeling diode path, there is a no opposition for the inductor current. Okay, and as we know the tendency of the current always follows the path with lesser opposition. Okay, so here inductor will prefer to release the energy through the freewheeling diode only. Okay, so when inductor releases the energy through the freewheeling diode, okay, at that time this voltage, right, this voltage will appear as a reverse voltage for the thyristor T1 and our thyristor T1 will turn off. Our thyristor T1 will turn off. Are you getting the point? Okay, so at omega t is equal to pi, right, or from pi to pi plus alpha, inductor starts releasing the energy through freewheeling diode. Okay, so now when inductor releases the energy through the freewheeling diode, what is the voltage across the freewheeling diode? It is a 0, so the same voltage will appear across the load. Okay, so V0 is equal to 0, right? V0 is equal to 0 volt. Are you getting the point? Okay, I0. Okay, so from pi to pi plus alpha, I0 inductor is releasing the energy. Okay, so inductor is releasing the energy, and definite comparatively this interval pi to pi plus alpha is very small. Okay, so therefore the current will remain constant. So I0 will be constant current, right? I0 is constant current from pi to pi plus alpha. Okay, because our inductor value is a high. Okay, next, so what is the freewheeling diode current? Can we write IFWD is equal to I0 during this interval, right? So now I0 is constant current, so it is a I0 only. Okay, next, what is the VT1 during pi to pi plus alpha? If you check, both the thyristors are in the off state. Okay, both the thyristors are in the off state. Okay, or you can apply the KVL to either to first loop or KVL to the outer loop. Okay, we'll be getting the answer. Okay, suppose if we apply the KVL to the first loop, okay, so it is like minus Vs minus Vt1, yes, minus V0 is equal to 0. Out of that V0 is 0, so therefore we can write Vt1 is equal to minus Vs, Vt1 is equal to minus Vs. Okay, so from pi to pi plus alpha, I0 is constant current, V0 is 0, and what is Vt1? Vt1 is minus Vs. Okay, it is a minus Vs. Next, now from pi plus alpha to 2 pi, what will happen? From omega t is equal to pi plus alpha to omega t is equal to 2 pi. Let us discuss what will happen. Okay, so now here from pi to pi plus alpha, inductor has released the energy. Okay, so from pi plus alpha to 2 pi, pi plus alpha to 2 pi, let us discuss what will happen. Now at pi plus alpha, we are applying the gate signal to thyristor T2, right? So therefore our thyristor T2 will turn on. This is the RL, this is VT1, this one is IT1 plus minus pi plus alpha 2 pi. So it is minus plus Vs minus plus Vs because supply voltage is negative. Okay, this is IFWD, this is VT2, this current is IT2. Okay, this voltage is V0 and current is I0. Okay, now so from pi plus alpha to 2 pi, what will happen? Yes, now we have applied the gate signal to thyristor T2, so current will be flowing from Vs T2 load and again back to the Vs. Okay, means again the inductor goes on storing the energy, so polarity will be plus here and minus here. Okay, polarity for the inductor voltage, okay, it is a plus here and minus here, right? So now inductor is storing the energy, inductor is storing the energy. Next, what is the VT2? VT2 is 0. Can we say that thyristor T2 is in the forward conduction mode? Yes. What about the thyristor T1? It is in the reverse blocking mode. Okay. Next, what is VT2? VT2 is equal to 0. Next, what is V0? Yes, if you check V0, apply KVL, it is a minus V0 plus Vs is equal to 0. So V0 is equal to Vs. V0 is equal to Vs, right? So VT2 is 0, V0 is equal to Vs. I0 is constant current, right? Because inductor will oppose the change in the current. Okay, so definitely we'll be getting the constant current. Okay, if we reduce the value of the inductor in the load branch, then we'll be getting some changing current. It is an increasing current, and again for the next interval it will be decreasing. Okay, so now next, so V0 is equal to Vs. Now what is the VT1? Yes, if we apply KVL to the outer loop, we will be getting minus Vs minus Vs minus VT1 is equal to 0. So VT1 is equal to minus 2 Vs, right? VT1 is equal to minus 2 Vs. Okay, so if you check from omega t is equal to pi plus alpha to 2 pi, means during this interval V0 is same as that of the supply voltage. Okay, next I0, it is a constant current, and VT1 it is a 2 Vs. Okay, VT1 is 2 Vs. Next, what about the 2 pi to 2 pi plus alpha? Next interval 2 pi to 2 pi plus alpha. 2 pi to 2 pi plus alpha. Right, 2 pi to 2 pi plus alpha. So now pi plus alpha to 2 pi, inductor has stored the energy. Okay, and if you check the current flowing through the inductor is a I0, it is a positive current. So direction of the current will be from right to left. Okay, direction of the current is from right to left. Right to left. Okay, next, after 2 pi supply voltage polarity is reversed. So plus here, minus here, here it is plus and here it is minus. Okay, so this supply voltage will try to circulate current in this direction. but here we are having thyristor T1 is in the off state, so this current will not be flowing. Okay, next this supply voltage will try to circulate current in this direction. Okay, but here we are having the inductor. Whether the inductor will allow the sudden reversal of the current? No. So whatever the energy stored by the inductor from pi plus alpha to 2 pi, inductor will release that energy. Again, inductor is having the two paths available to release the energy. Inductor can release the energy either through the freewheeling diode, or inductor can release the energy in opposition to that of the supply voltage. But if we check, if inductor releases the energy in opposition to that of the supply voltage, there is a opposition of supply voltage to the inductor energy. Okay, and as we know, the current always follows the path with lesser opposition. So therefore, inductor will prefer to release the energy through the freewheeling diode. Okay, so that's why the energy will be released through the freewheeling diode. Okay, so now here if you check, when inductor releases the energy through the freewheeling diode, what about the thyristor T2? This voltage Vs will appear as a reverse voltage for thyristor T2. So our thyristor T2 will turn off immediately. Thyristor T2 will turn off immediately. Okay, so if you check, during this interval freewheeling diode will be in the conduction mode. Okay, next what is the V0? V0 is equal to 0 volt, because voltage across the conducting diode, which is equal to V0, which is equal to 0. Okay, next what about the I0? Inductor is releasing the energy, so I0 will be constant, because here inductor value we have considered is a high value. Okay, next what about the thyristor T1 voltage? VT1, yes, is equal to, if you apply KVL to either to the first loop or KVL to the outer loop, yes, we will be getting it as a plus Vs minus VT1 plus V0 is equal to 0, right? So VT1 we can write, it is a plus Vs minus VT1 minus V0 is equal to 0, right? So therefore out of that V0 is already 0, so VT1 is equal to Vs, right? Voltage across thyristor will be equal to Vs. So here if you check, VT1 is equal to Vs from 2 pi to 2 pi plus alpha. What is V0? V0 is 0. Okay, next what is I0? I0 is constant current I0. Okay, so again if you check, one complete cycle of the supply means 0 to 2 pi. Okay, so here the interval 2 pi to 2 pi plus alpha is nothing but which is same as that of the 0 to alpha. Okay, so from 2 pi to 2 pi plus alpha, I0 is constant current. So for continuous cycle, here also we will be getting the constant current I0. Are you getting the point? Is this clear? Okay, so here during alpha to pi, T1 is in the on state, pi to pi plus alpha, freewheeling diode will be in the on state, right? Means during this interval inductor is storing the energy, during this interval inductor is releasing the energy, after that again inductor stores the energy, after that again inductor releases the energy. Are you getting the point? Okay, what is the difference between the output voltage waveform in the case of RL load without freewheeling diode and RL load with freewheeling diode? If you check the V0 waveform, in the RL load without freewheeling diode case, yes, there was the negative pulse in the output voltage, but here the negative pulse is absent. So can we say that the average output voltage in this case will be greater, improved than that of the RL load without freewheeling diode? Okay, so this is about the circuit operation of RL load with freewheeling diode, single phase full wave controlled rectifier. Okay, in the next video we are going to discuss the derivations of this circuit. Thank you.